Hello everyone, welcome to Simplilearn's YouTube channel. Today we will be discussing about the core Java projects. So before we begin, I would like to tell you guys that we have daily updates on multiple technologies. So if you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and hit that bell icon to never miss an update from us. Now, let's have a quick look on the agenda for today's discussion. So we will be dealing with two projects today, which is ATM machine and calculator application, and the source codes for these particular projects is linked in the description box below. You can have a check on it and you can try the projects on your own as well. I hope I made myself clear with the agenda. Now over to the training expert.
Hello guys, this is Vikesh and let's get started with today's topic, which is about walking through a particular project using all the concepts which we have learned so far. So in this session, we are going to focus on a particular project, and the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hash map class, we are also using a scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to PIN mapping. So we create a map, and inside the get login method, we add couple of entries to the map. Here, the first entry, the first integer, is pointing to the customer number, and the second integer is pointing to the PIN of the account of this particular customer number. So if we call the get login method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called set customer number. Again, I will come back to that. And once you have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks. But things get interesting in this method. So what we covered so far was the get login method. Let me close this method here. So we covered the get login method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. Again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sysout. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here based on the customer types 1, 2, 3, or 4. The corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called, and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund, and for that also I have defined a method. I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to the account class now. So this is the account class where I have defined some private member variables like customer number. So now you will be familiar with the customer number, PIN number, which I just described, and also with the checking balance and the savings balance. You can also divide this account class into two child classes, where you have a savings account class and a checking account class. But for simplicity, I've kept it to one class. I'm initializing a scanner input which will be used at multiple places, and then I have the setters and getters for these four member variables. So you see set customer number, get customer number. If you remember, this set customer number was called in the option menu class. If I go back to the get login, once we ask the customer to enter the customer number, we call the set customer number, which gets called here. Similarly, we call the set PIN number, which gets called here. Similarly, once we have said that, we were fetching the values using the get customer number and the get PIN number, and that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these two methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have two methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have two more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined 4 calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit. Basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input, and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class, and if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. Then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these 4 calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called, and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line, the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class. We talked about the account class, And now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the getLogin method. Remember, getLogin was the first method which asked you to provide the customer number, and then getLogin called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the get account type, and the get account type method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the get checking method. And the get checking method again provides you with another menu, view, withdraw, or deposit, or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option, because inside the get checking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class, and this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw, so I choose the option 2 as the choice. Current balance is 500 and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100, and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calc checking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here get checking withdraw input got called. Here, this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise, your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method, where it will again ask you to enter the customer number. So this is how you can run this application. And this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. And this is all I want to cover in this particular session. And in the next session, we are going to have a look at another interesting core Java project just to build our understanding more better about the core Java concept.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with walking through a core Java project using all the different OOPS concepts we have learned so far. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9, the current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2, and whatever value it gets, it is going to store a value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the getResult based on the expression. And whatever result we get from the getResult, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the getResult for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by 0 scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. So that's all I want to cover in this particular session. If you like this video, a thumbs up will be massively appreciated. Thank you, and we'll meet again in the next session.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.